Hello, and welcome back to another episode of Kerbal Space Programming. Kevin here, and this is a bit of a side episode, I guess, or a bonus episode, because we didn't really do any coding in the previous video, but I did point out that we are overdue for some revisions to our library scripts and our boot scripts and various things. So I want to kind of walk through revising some of our scripts. Now, we're not going to do a ton of revision just yet because there are some big updates coming in the next version of KOS that I'm trying to kind of hold out for before we go into kind of refactoring some of our library functions. But one of the key parts of our space program is the boot file. And I've got the boot file that we've been using on the right here, and it's a long file. It's 107 lines and a lot of characters, and it's got a whole bunch of kind of utility functions in there, but it's a little bit of overkill in some sense. There are a couple of functions that we don't really use, like download, simply because it has been a little bit iffy in the past. That basically not download. Download's been fine, but require has been an issue just because of the way that KOS handles caching of files. That we check if there's a name, it'll download the name, and then it'll rename it to temporary.exec.ks, and then it'll run temp.exec.ks. But if we do this multiple times, well then KOS is going to run the first thing that it found at this file name and won't reflect the new version. So we've, in practice, not been using this function in a lot of cases. The other important thing is that now that we're dealing with various craft that are docking with each other, and we have ships that have multiple cores on them, we've got a little bit of an issue in that all of this boot script stuff and all of the ways that it grabs updates to the craft is based on the ship name. And if 3 cores are running and they're checking for the ship name, well then they're going to run into some issues. So what I want to do is kind of look at how we could refactor our boot script to be a little bit smaller, and so that it can continue to function in this new land of multiple cores on a particular vessel. So we have all these functions here, and you can see it's got a whole bunch of, here we see it says the actual boot up process, and it checks for an update script and downloads it, and then it checks to see if there's a startup script, and then it waits 10 seconds, and then it reboots. This rebooting is something that I think we eventually want to just get rid of. Unfortunately, when you reboot the module, it's going to go ahead and it's going to run that boot file, but it's also going to take a few seconds to compile the boot file, which introduces a bit of lag. You may have noticed if you try and run a very, very large file that your KSP game will freeze up for a second or two, which is fine. But when we have this wait 10 seconds thing in here and we go into time warp, that means that we are causing that lag just about all of the time, unless our script is running an existing set of instructions, and particularly when we're dealing with multiple cores, that gets to be a bit of a problem. So I want to take a look at the script and see what are the things that we actually want to do. Now, if we take a look at the top, the first thing we do is we set the ship control pilot main throttle to 0. Now, this seems like something that we definitely want to have, so I'm going to yank that over, and we're going to reformat it to lowercase because that's what we're doing going forward, because this is something that I wish KSP just did by default, that if you have something on the launch pad and you haven't touched the throttle, just put the throttle at 0, not 50%. Because if your craft finishes its execution and then the program ends, then all of a sudden you're going to be throttling, and you don't necessarily want that. So we've got all these functions here, but I'm going to pass over most of these functions for the time being and just look at what we're actually doing as part of the actual boot up process. So let's see, we're setting an update script to the ship name. We'll get to that later. If we've got a connection, we check if there's an update script, we download the update script, and we delete it from the archive, and then we check to see if, check if up.ks, we delete, that doesn't make sense. Oh, because we're naming that update here. Right, okay. So we're doing all of this. So basically, this is just checking to see if we have a connection and if there's an update script, and if so, we're going to fetch it, we're going to delete it from the archive, and then we're going to run it. We have to rename it to something that's known because you can't say run update.ks like this. You have to put in a hard file name. So then we check if we've got a startup. Otherwise, we're just waiting. We wait until we have a connection, and then we reboot. Okay. That's fair enough. Now, this is a lot of code, though, and if we have to look at all of this, this is a lot of kind of details as to how things are implemented. I want to think about how we want our code to actually run, what we want our system to do on boot up. So I'm going to go ahead and just start kind of prototyping here. So what we have initially is we have something like if has new instructions, and if that's the case, then what do? Well, we say run new instructions. Now, we're not describing the checking if it has a file. We're not describing whether or not there's a connection and that sort of stuff. Then we'll say if has startup script, or sorry, else has startup script. Not else. If has startup script, then run startup script. And in our original, we also have this condition where we wait to see if we have a connection, then we wait an additional 10 seconds, and then we reboot. We're actually going to get rid of that, just because it ends up causing all of that lag. We were trying to do this for realism, but the reality is that if we switch away from the craft and we switch back to it, then that's always going to be the case, and we can always go in and manually reboot things. So just for the sake of kind of making these videos a little bit cleaner and more performant, we're going to ignore that step of kind of continuously polling, so that we don't run into issues. So now we've got kind of the basic idea of what we want our script to do. And in fact, we can even clean this up by getting rid of these braces, because when you have a single instruction, you don't actually need a block. So I'm going to go ahead and do things like this. And this is our actual boot up process, right? And actually, we'll go ahead and put that in here. So this doesn't need to run every time things boot up, but it definitely needs to run the first time the things boot up. And that's what we want. So now we understand kind of what our boot up script is trying to do. It wants to see if there are new instructions, and if so, it's going to run them. Otherwise, it wants to see if we have a startup script, and if so, it wants to run a startup script. So we've got a bunch of functions here that need to do things. So let's prototype them out real quick. Has new instructions. And this needs to return true or false. And we've got a function run new instructions. And this needs to do things. And we've got a function has startup script. This needs to return true false. There we go. And function run startup script. Do things. Right, okay. So let's start thinking about this. Has startup script and has new instructions are probably going to have some similar bits of code. So let's think about how we can, let's start with just has startup script, because this one is probably the easiest. We can think about, well, how do we know if there's a startup script? We'll say local found startup is 0. Remember, you can kind of use 0 to be false and 1 to be true, just because there are fewer characters, and we want to make sure that we're not taking up a whole bunch of disk space just to manage our boot up. So we'll say local found startup is 0, and then we'll list files in all files, and then we'll say for f in all files, if f name equals startup.ks. We'll say set found startup to 1. So we'll set it to true. So we're getting all of the files on our current directory, and we're saying for all of them, if the name is equal to startup.ks, then we're going to say, yep, we found it. So we'll set that variable. And at the end here, we'll just say return found startup. So this should do what we want. It's going to grab all the files, go through all of this, and then return 0 or 1, because if this never changes, then it's going to return 0. Now, if we think about has new instructions, this is going to be relatively the same, right? So we'll go ahead and say, we'll just go ahead and copy this in here for now. Oops. Now, we're not looking for found startup. We'll say found instructions. Actually, let me just replace that across here. Found startup with found instructions. All right, and there's another issue here in that we actually want to be looking for some arbitrary name here. We'll put in new instructions for now. And there we go. So this is going to do all the same stuff, but there's a bit of an issue in that we're not checking for new instructions on our own local hard drive. We need to switch to the archive volume to do that. And then at the end, we need to switch back to 1. All right, so I'm just going to move, since these two functions that we've scoped out, coded out are checks, and these are actual executions. We'll just kind of group these together for the time being. Now, one of the important things to note is when you're coding is that if you find cases where you're copying and pasting, it generally means that there's a case where you really should be using a function. Because otherwise, if we make some minor change, we realize there's something small here. We've accidentally typed lists X instead of list, and we've copied and pasted that over here. Well, then there are two places where things could break, and we really want to have this all sort of consolidated. Also, it'll help us save a bunch of file space. So we're going to go ahead now, and I'm going to say function has file. Because this is what we're checking for most of this, right? We're just checking if it has a file and returning true or false. And I'm going to go ahead and I'm going to say it's going to take parameter name. And we'll say list files. Well, no, we're going to go ahead and we're going to grab the same local found type of thing. So we'll say local found is 0. Because now we don't necessarily care what we're, it doesn't make sense to say found instructions or found startup because it's not scoped to any of these particular functions. So we'll say local found is that, and we'll say list files in all files. And actually one of the other things, I'm going to use underscore case here. I'm going to say for f in all files, if f name equals, and we've got the parameter name that we passed in, and then we can say set found to 1, and then we'll say return found. Right, so now this is more of a general case. We've got the logic that actually finds these files, separated out, and so we can call that within both of these has new instructions and has new startup script functions. So we're going to go ahead and say we can take this out, we can take this out. We'll say switch to that. We'll say local result is has file, and whatever we're looking for, instructions.ks or whatever, just for now, for prototyping. And then we'll switch back to the local volume, and then we'll say return result. And that's fewer lines of code. This one is much easier because we don't have to do this switch stuff, so we can simply say here return has file startup.ks, and then we can get rid of all of these lines of code because we don't have to do any cleanup or setup before we actually call this this function. So in fact, we really kind of almost don't need this function, but it provides some clarity when we're looking at our boot up process as to what we're actually doing because it's in the name of what we're actually looking for. So that's a little bit nice. We're going to go ahead and keep it like that. Now let's take a look at this hasFile function and see if we can tidy it up a little bit. One of the things that we want to try and do is reduce the number of characters if possible. And in fact, because we don't have any cleanup, because when we were writing this one, we had to put in this switch thing before we returned, but because we don't have to worry about that now, we don't actually need to save this temporary variable, right? If we find something that matches the name, well, we can just go ahead and return 1. We can say we found it, don't bother continuing in this loop. And here we can just say return 0. And that means that we don't need this found variable anymore. So the other thing that I'm going to do is I'm just going to tidy this up a little bit. I'm going to remove this block because remember, if you have a block that is just a single instruction, you can replace it with the single instruction. And I can actually do that again here. And now if we look at what we've done, we've taken kind of two relatively hefty functions that were doing something pretty similar, and we've combined them into a single function. We've also cleaned this up to be really, really nice. We say list file in all files, and if we find it, return 1, otherwise return 0. And actually, I'm going to do one more refactor here. I'm just going to change all files and make it fs, just to make this even smaller, right? And we can take this parameter n, and we can take that here as well. And this is just saving us some characters so that we're not going to be taking up a whole bunch of extra space. And generally, you know, when you're writing out stuff for the first few times, you want to use very descriptive names, but because our function name is very descriptive, the fact that it's very few lines of code means that we can go, okay, I have a feeling I know what's going to happen if I call a function called hasFile. It's going to return true or false, and I don't necessarily care when I'm in the context of these other functions what it's actually doing. And if I do care, then I can go ahead and take the time to figure out what these files are. So we say for f in all of these fs's, which is this list that we created here. If it has the name, we'll return 1, otherwise we return 0. Alright, so the next thing we want to do, we've got 2 more functions that we want to tidy up. So we've got run startup script. Well, that should be pretty darn easy, right? We've already checked to make sure that the file exists, and that's not the job of this function to know whether or not it exists. The fact that we're calling it means go ahead and try it, and if you fail, it is the person who's calling its fault. So we'll say run startup.ks. And that's all that we need for that function, right? That is nice and easy. Now, the problem here is that we've got run new instructions, and this is a little bit obscure because it's not just run new instructions. We also want to actually grab the new instructions as well before we run them. So I'm going to go ahead and change the name to fetch and run new instructions. I'm going to change the name of instructions to, I don't like that this is overflowing. Command. We'll name it, well, let's call it, yeah, command. It's fine. And we'll change this to command as well. And then we'll go ahead and go up here. We'll change this to command. And change this to command. Alrighty, so run new command. Now we need to figure out this. This is fetch and run new command. Now we could go in here and start actually writing the code for this, but this is doing 2 things, right? I'm not a fan of doing 2 things. I'm a fan of doing one thing and doing one thing particularly well. So let's say fetch new command and then run new command. That's all that this function is supposed to do. Of course, it does imply that we need 2 additional functions though. So let's go ahead and start writing those. We've got function fetch new command and function run new command. All right, so fetching the new command. Let's say we've got to, and now at no point do we actually know what this name is though. And this is part of the problem. So we've got this, well, we're using instructions.ks for right now. So let's go ahead and say fetch new command is just copy instructions.ks from, and actually we don't even need to stringify that, do we? From 0. And that's theoretically all that needs to do, right? That's all that needs to happen. If we're just going by the name of this function, this does what the name of this function says it's going to do. And then we've got run new command. And this is, well, that should be pretty easy, right? Run instructions.ks. So now if we're looking at kind of our boot up process, we've got setup shift control pilot main throttle to 0. That's a bit of actual code. And then we've got these functions that are describing the behavior. We're saying if we have new commands, then fetch and run new command. Otherwise, if we have a startup script, run the startup script. And if neither of those are the case, this program is just going to end, and that's fine because we can always reboot things manually or by switching away. And then if we go into any of these functions, we can immediately see kind of what they're doing. HasFile is not part of that. It's a sort of a helper function, but we've got hasNewCommand. It's going to say, okay, I'm going to switch to 0, and then I'm going to check and see if it has a file. And then I'm going to switch back, and then I'm going to return the result. We go, okay, I have a general understanding of what that's doing. We go has startup script and say, I'm going to return whether or not you have a file called startup.ks. Well, that's perfect. And then we look at all of these, we say fetch and run new command. Well, we can understand what this is doing without ever really having to know what the actual code behind it is. We say, okay, it's fetching the new command, running the new command. This stuff becomes really, really dirt simple. We don't have to go, oh man, what is the syntax and how's this working? Because we've got everything written up into these various functions. Now, there is one little problem though, and that is that when we copy instructions.ks, well, we've got this hard-coded instructions.ks value. I'm not a fan of that, because then any CPU that happens to be running will go ahead and go, hey, there's an instructions.ks. I'm going to go ahead and download that. We don't necessarily want that. So instead, I'm going to use, we need a way to actually distinguish the instruction name. So let's go ahead and write another helper function. I'm going to put this up here. I'm going to function command name, right? And this has to return expected command name, file name, the name that we're going to look for on the archive. And now there's a little bit of an issue with this, and that is that we can't hard code this in. This has got to be something that's going to vary between certainly craft, which is what we did in our existing update script, where we have set update to ship name plus .update.ks. But we really want it to vary based on the CPU. And one of the ways that we can easily distinguish the CPU is by tag name. So if I switch over to telnet, I've got a craft on the launchpad that's just sort of sitting out there. And so I can say print hi, and it'll go ahead and run that. One of the things that we can do is I can say print core. And you see it's getting us a KOS processor. It's got a whole bunch of actions on, that sort of thing. And this is the currently running CPU. So I'm going to get its part. And we get, okay, it's a thing that's a part. And I'm going to, is it tag or tag name? No, print core.part.tag. Right, so this one doesn't have a tag. That's a little bit frustrating. But I can set it to something. It's just not something that I set in the VAB. And now if I get it again, well, there we go. It's hello. And this is only going to change if you explicitly change the parts tag name or if you set it up in the VAB. So we can actually use this to distinguish between CPUs that may be running on the same system. So if we jump back over, let's go ahead and think about how we can do this. We can say if. Now, we already illustrated that there's a little bit of an issue in that it may not have a tag name. Let's say if CPU has tag name, or core has tag name. And otherwise, right? So if it has a tag name, return something based on that name. Otherwise, return, well, what do we want to do otherwise? If the core doesn't have a tag name, well, then we've got a little bit of an issue, right? We need some, if a whole bunch of cores exist that don't have tag names, then they're all going to be looking for some blank file, which isn't what we want either. What we really want to do is actually set a tag name and then return something based on that name again. Okay, so there we go. We can get rid of that. And now, one of the interesting things is when we're looking at trying to really use functions in a crisp and clear way, a good indicator is when you find yourself writing out kind of prototype comments, generally that means that it should be a function, right? So let's go ahead and say build command file name. And we're going to base that off of core part tag. And that can be the same thing here, right? So we've got set a tag name, which needs to do something. But then at the end, it's that. So we'll go ahead and say return this. Right, okay. So now we've got the set a tag name thing. So let's just go ahead and say create, let's see, assign core tag name. There we go. Now we've got our basic functionality. So we've got command name, and it says, okay, if the core has a tag name, it's going to build the command file name based off of the core's part tag. Otherwise, it's going to assign one first and then do that. Well, now this is a little bit stupid, right? Because we're doing the same thing twice, and that's not good. Either way, we're returning this line of code. We just have to do something extra if the core does not have tag name. So if not core has tag name, then we're doing this assign core tag name thing. And then we can get rid of all of this. And this is exactly the same. Now, of course, now we're discovering that we have even more functions that we want. So we'll say core has tag name, and we've got a function assign core tag name there. And okay, so core has tag name. Well, how do we do that? Let's think about this. If core part tag equals empty string, then it does not have a tag name. Otherwise, return true. Right? We can verify this by looking here, and we could say, well, I guess, yeah, that's sort of cheating now. But by default, if the tag is not assigned, then you're going to get an empty string back. But if we were to look at equals empty string, let's see. Oh, right. Yeah, there we go. Okay, now it's printing out false because they're not equal. So, okay. So this is not true, and so this would get bypassed in that case on the test graph that I've got out on the Launchpad, which is great. That's what we want. So this does what we want. We'll go back and clean it up in a little bit, but let's move on to assign core tag name. So this is a little bit trickier because, well, we know that we're going to say set core part tag to something. Let's go ahead and call it name for now. And that means that we have to have a name. So we'll say local name is empty string, just for now. We'll go, okay, so we've got a local name is empty string. And now we need to actually figure out a way to build up something that is random and likely not to coincide with other parts, right? So this is really kind of an edge case of if we forgot to assign something in the VAB, then it at least has an identifier via which we can upload instructions to it. So one of the ways that I'm going to go ahead and try and do this is by using the random function. Now this comes with KOS, so if we type in here random, well, if I type print random, now we get this random string of numbers, right? Now that's great, but I'm not a huge fan. Let's go ahead and tidy it up a little bit. If we add an empty string to it, then we get it as a string. You're not going to see quotes or anything there. But if we take this and we add an empty string, now we have a random number that's between 0 and 1, but as a string, and it's generally many digits. And I'm going to go ahead and I'm going to say delete or remove. Is it remove? I think it's remove. 0, 2. Yes, it's remove. What this is doing. And let me assign real quick, set x to random. And then I'll just, instead of printing out random, I'll print x. There we go. So we got that, and the original x that we had is 0 point this. So remove is just removing the first 2 characters from the string. So we give it an index that we want it to start at, which is 0. We give it the number of characters we want to remove. That's perfect. So basically, now we get this lovely number that doesn't have dots in it, which is kind of what we want. Now, it's entirely possible that we could get a number back that's like 0.1, and that's not necessarily the best. We probably want something that's a little more unique than that. But actually, let's go ahead and look at this, and I want to just print off the length of this. It's 14 characters long. That seems like a good enough solution. Right? So if we look back here, we've got, okay, let me get rid of that. Let's go ahead and say until name length is equal to 14. We want it to be 14 characters long. Let's just start adding random numbers to the name. Set name to name plus random plus empty string, remove 0, 2. All right, so we're just taking the name and we're tacking on something that we get back out of it. Hopefully that'll be 14 on the first try, but maybe it won't. And then, of course, if it's over 14, well, then we've got a little bit of an issue. So let's say that we did this multiple times. Let's say set name to empty string, and then we'll say set name to name plus random plus string, remove 0, 2. And print name, we've got this, and print name length. Well, that one is 16. All right, so now we've got too many. So let's go ahead and try getting a substring, 0 and 14. There we go, there's that. and we'll take the length of that just to make sure. There it is, it's 14. Now what happens if we have something that is shorter than that though, right? Because then this could crash. So let's say print, whoops, all right, print empty string substring 0, 14. Well, now we get an issue that the parameter name length is let's see. Yeah, start length plus this is the length, parameter name length. Yeah, it's not happy about this because it is we're trying to pull out a portion of the string that is larger than the original string itself. So let's go ahead and tidy that up. We'll have to make sure to check that. So we'll say if name length is greater than 14. We don't want to run it all the time. We do want to run it some of the time. And we'll say set name to name substring 0 and 14. And remember, what substring is doing is it's taking the starting index, so the first character of the string, which is index 0, and then we're just taking 14 more from there. And this is just to make sure that we don't end up over it. So if this is less than that, then we'll go ahead through this loop again and we'll add on another random number. And otherwise, we'll go ahead and trim this to 14. The next time it hits here, it'll go, oh, yep, you're 14. Move along. Right. Okay. So now we've got this. This isn't great. We'll tidy it up. We'll come back to it. But we have all of our functions written now, and we just need to figure out how to start piping this command name stuff back into our original stuff. So if we have new commands, well, that's easy enough. We'll say command name in has new command. And let's find the other places where we have instructions.ks. Copy command name from KOS. And now we've got a little bit of an issue in that if we try and run command name, this is not going to be happy. You can't run expressions. You have to run a hard-coded value. So instead, what we're going to do is we're going to use that copy trick that we used in our original script. So we'll say rename command name to tempexec.ks and then run tempexec.ks. And, you know, that's a little bit ugly. I believe that there are efforts underway to actually allow you to run expressions, which would be great. But for the moment, that is what we're looking at. So, fair enough. Now we've got everything that should be working. Let's take a look back up here and see if there are some ways that we can tidy some of this stuff up. So we've got core has tag name. If core part tag is this, return false, return true. All right. Well, you know what? We don't actually have to do this whole if and then return false and return true thing. We can simply return whether or not core part tag not equals false, because that's going to return if it has no tag name. We want to say not equals. There we go. So this will return if the tag is not equal to an empty string. We're asking if the core has a tag name. If it has a tag that's not equal to the empty string, it'll say true. And if it has a tag name that is equal to the empty string, it'll say false. So this tidies this up nicely for us. Now we've got assign core tag name. This is a little bit messy. Let's see if we can tidy this up a little bit. First thing I'm going to do, just to make this a little cleaner, is I'm going to change name to n. There we go. And of course, this makes this a little bit less readable, but it's also going to make things a little bit nicer when we start inlining things. We've got this. And we've got set n to this, remove, great. And this needs to be a block because it is these two commands. And we'll say set core part tag to n. You know what, that is, I think that's about as good as we're going to get with this one. Let me think, is there? Yeah, I think that is about as good as we're going to get. Yeah, okay. Let's move down to this one. If not core has tag name, well, easy enough. That's a single instruction. We can tidy that up. And yeah, I think we're starting to look a lot cleaner here. One of the things that we could even do here is inline these smaller functions here, like these one-off functions. Just kind of move these up by each other. This is another one that's, you know, very small. Actually, if I cheat a little bit and just unzoom, so it's not quite as zoomed up as much as normal, then we're probably fine. Has startup script return startup, run startup.ks, good. this, all this stuff. And so you see now if we look at this code, it is a lot more readable because when we're trying to evaluate an individual function, we can look at only a few lines of code. And when we're trying to look at these larger functions that rely on other things, we can just look at the name of the function to determine exactly what it's trying to do. But of course, there's a little bit of an issue. We're at 56 lines. We're also not doing any of this RemoteTech artificial delay stuff. And I think this is something that I'm ultimately going to get rid of just because I've not found a good way to model it. And this, it ends up requiring a whole bunch of additional overhead for managing stuff. So I think we're going to get rid of this. I want to test real quick and just see what is the character count, because that's the file size that KOS actually deals with. So I'm going to type word count and -C to get that. And this is just shelling out to the command. No? Oh, right. I have to actually pass it the file. There we go. Okay, and we say it's 2455. So this was taking up, our original boot script was taking up about a quarter of our hard drive just to get things set up. And if we run this against our new thing, well, it's much smaller. That's good. On a default regular drive, now we've got, 89% of our space available. But I think we can clean this up a little bit. Now, to do that, though, we actually have to make some sacrifices. We have to sacrifice some of the cleanliness of this readable, wonderful code. So before we do that, I'm just going to go ahead and save this as our nice, clean code. And actually, even just removing those extra lines is going to take down a few characters. See, we're down 2 characters because these new line characters also count as characters. So I'm going to go ahead and save this, and I'm going to copy it to episodes. EO28 expanded boot file .ks. Right, and now what am I? Yeah, okay. So yeah, I'm just saving a copy before we go through and start mangling all this stuff. So as nice as it is to have all of these functions as kind of, especially these small ones that make things nice and readable, it does mean that we've got all of this overhead, all of these character overheads of having, all of this in place, which isn't necessarily the best thing, especially when we're only using things like this once. If we're just trying to check if core part tag is not equal to empty string, well, maybe we should just inline that, right? Because this is an awful lot of characters just to manage that whole thing. So let's go ahead and start doing some of that. So let's check core has tag name real quick. Has tag name. And there are only 2 instances here. And because the actual body of this function is much smaller, we can go ahead and start inlining this. So we'll go ahead and just for the moment, I'm going to go ahead and say core part tag not equals this. And there we go. So we've taken this body of the function, and this is one of the principles of functions, is that if it's not a mutating function, that is, it doesn't change the state of anything, then you should be able to replace the body of the function for where it's actually called. And we can delete this now. Now, of course, this is a little bit dumb. We've got this not condition. Let's go ahead and change that, because we can get rid of the not by saying if it's equal to, there. So we'll say if core part tag is equal to empty, then assign core tag name. That's great. Assign core tag name, I'm inclined to say let's go ahead and keep that as its own function, at least for now. And if we want to get more rigorous about things, we can in the future. Let's grab these smaller functions, because they're likely candidates to be abstract or to be copied back in. Let's say has startup script. Oh, and that's down there in the place where we really want it. That's a shame. But okay, I'll split and jump down to the back here. If has startup script, let's go ahead and inline that. So we again replace the function with just the body of what was in the function of the return value. Let's say has file startup.ks. And now this isn't anywhere near as clean. It makes me sad, but it's going to reduce our character count a lot. So let's go ahead and get rid of that. And there were no more cases of that, right? Yep, nope, that was the only one. Run startup script. That's the same thing, isn't it? Run startup script. It's just those 2. We'll go ahead and replace in the body run startup.ks and get rid of that. And if we take a look at our word count now, all right, see we've trimmed about about 80 characters off, and we're only really just getting started. Fetch new command, that's the next one that's up. Fetch new command. Well, that should be easy enough. Let's find where it's being used. It's being used in here. Say copy command name from 0 and gone. And just with that one function, look at that, we're already down an additional, roughly 50 characters for doing that. So, okay, fetch and run new command is another one. Let's see, run new command. Now, see, all of these are relatively meaty in that they are actually doing legitimate things. Let's go through this manually. Assign core tag name. Yep, this is a block of code that we don't necessarily want to inline into places. If that, assign core tag name, that's calling that. Build command file name. Where is our build command file name? Oh, huh. Well, that's funny. We didn't even write our build command file name. Let's go ahead and write that real quick. Build command file name. And it's taking in a core name, a tag. It's taking in a tag, and let's say return, to start us off, let's say tag plus dot update dot ks. Now, of course, now that we've written it, we can see this is one that's almost immediately going to get thrown back in, back into place. Now, of course, we're using it in a couple of different places, so let's actually find all of those. Okay, yeah, we're just using it. Wait, we're just using it there? Really? Right. Okay. Yes. Yeah, okay, it's only being used there. That's fine. Let's look at the body of that, and we'll replace it back in. Except this time it has an argument, so we'll want to be a little careful. Return core part tag plus dot update dot ks. Right, and we want to go ahead and keep this one, I think, as a function, even though we could technically inline it, because it's running in multiple places. We want to make sure that any time that we're checking for that command name, we're assigning a core tag name if it doesn't already exist. So, okay, we wrote that wonderful function. Now we can get rid of it again. And let's just look through here and see if there are any other likely candidates for things. Fetch and run command, copy command name, run new command. Let's see. Rename command name to that, run command name, Yeah, see, we're using command name in a lot of different places. And so, yeah, it probably doesn't make sense, because in this case, actually having it in a function probably saves us characters, because if we were doing that checking for the core tag all of the time, then we'd have to copy and paste that multiple times. It's going to end up being more characters. In some of these functions, we were calling them functions just to make the readability a bit easier, but in KOS world, character count really kind of is the enemy, and so we want to be really careful with that. So copy command name from 0, run new command, run new command. Run new command is probably something that can go away as well, even though it does make things really, really nice. Run new command. Yep, that's the only place where it's used, so you know what? We got to inline it. Goodbye, run new command. And now this isn't the worst. It's still somewhat readable, but, oh well. Has file command name, fetch and run, rename, run. All right. So this is actually getting cleaner, and it's fewer characters and lines. If we check again, 904, but we can do better. Assign core tag name. Yeah, okay. I think it's time for us to get into the ugly parts, the particularly ugly parts of writing these scripts. There are a couple of things that we want to do, and the one thing that I'm also going to do here is, because none of these, one of the things that we did in our old boot file is that we had some functions like hasFile that we used in other scripts. And I'm going to argue that this is actually a bad idea, that we've defined all these various functions like fetch and run new command and has new command and all of this stuff. But we don't actually want those to be available when other scripts are running. Those scripts are running in what's known as the global namespace, and we don't want to necessarily pollute the global namespace with all of these various functions, because then if somebody overwrites those function names, they may run into issues. Now we can get around this by putting all of this stuff into a block. And this is going to become a little bit easier once we start doing our very ugly refactoring. But this means that if I were to try and call assign core tag name outside here, then the system's not going to have any idea what I'm talking about because it can't find it. You can only run it inside the context of this block. So I could run it in here. There we go. So this is just a way that we're going to go ahead and make sure that all of the stuff that we're doing for our boot files is not going to pollute things that we might want to do elsewhere in different scripts. So, all right, now we're going to go ahead and save this again. I'm going to save this as episode 28, consolidated boot file.ks. And I'll have to go back into the original and make sure that we've got that create command name function put back in there where it should be. So this is a smaller version of our original script that we wrote, and 974 characters. And now here's the point where we start to just get really, really gruesome. And generally, if you're using if you're adopting the strategy with other languages, you don't actually maintain code this way. You're going to have a library that takes your code and creates a very small version of it, and then you never really edit that small version. You'd edit your main code and then run the library against your code base again. But because, as far as I know, nothing exists like that for KOS, and we could try to write one, but it would, it would mean choosing a particular language that you may or may not have access to or may have difficulty getting installed. We're going to actually go ahead and start minifying things manually. And if you're ever on a website, you may find JavaScript that is very, very confusing and uses these very compressed versions of things. That's basically just minification. That you take the code and you reduce to as few characters as you possibly can while preserving the behavior. And the easiest way to start off with that is to start deleting our comments. We don't need comments because this isn't for readability. This is strictly for minimizing file size. Next thing we're going to do is we're going to take a bunch of these long names. We're going to give them very, very ugly names. So I'm going to go ahead and start doing some judicious replacing. We're going to assign core tag name to A. And we're going to say replace all of them, but let me confirm. I'm going to say, yep, I want to confirm that one. I want to confirm that one. Okay, nope, that's all of them. Now, this is saving us a bunch of characters, right? Because here, this is how many characters? Fair number. Of course, A, we have no idea what A means. That's useless. But, hey, what are we going to do? This is going to go ahead and keep things very, very small. We'll go ahead and change command name to B, and let me go ahead and confirm that, just so that if we ever were trying to replace something that ends up being a partial string of something else, then we catch that. Copy B, and there, we've got those, and has file. Oops, has file C, and yes, and yes, and yes. Both those are gone, and has new command. Now we have used a couple of things like N inside these functions, so if we were doing this with a more complicated thing, we'd want to be very, very careful that we don't end up accidentally setting a variable name to something that we're already using as and actually we're using F for file, so we're going to have to be careful of that. Has new command. We'll replace that with D, and yes, and yes. And E, I'm actually going to be careful about. I don't think I want to call a function E because, well, E is a constant, and I think that let's check actually. Print E. Print E. Print 5 times E. No, okay, E's fine. Let's go ahead and use E. Well, actually, let's not use E, just because I'm a little nervous that it could eventually be used in the future and then would run into collisions there. I don't want to use F because we're using F for inside our file check. I don't want to use G because of the gravitational constant, so let's use H. Fetch and run new command. Oh, come on. And run new command. we'll replace that with H. Yes and yes. Alrighty, so now we have a code base that is inscrutable. There are no useful function names. We don't know what any of these things do. But as a result of this, we're down to 703, right? So we've trimmed off almost 300 characters more, and we can do even better. So let's start taking a look. Now, one of the things that we can do is we can take advantage of the way that, actually, while we're here, let's change this to S and S, because it's just, we were just creating a list. It doesn't, actually, let's make it L, because it's a list. And we'll say for F and L. At least it sort of resembles, it gives a little bit of a clue as to what's going on. That's fine. We've got local result. Let's change that to local R. R is being highlighted. That scares me. Let's change it to K and return K. Yeah, just looking kind of in the body of these to see if there are places where we're using variable names that could be smaller. And I think, nope, everything so far is looking like, yeah, all of these arguments are pretty much as small as they can be. They're single characters. Now, we can take advantage of the fact that KOS does not, or when you call a function, you don't need to use the parentheses. It's preferable that you do, but since we're all about file size at the moment, we can go ahead and get rid of those. I want to double check with random. Let's see, print random plus 5. Nope, it's not happy about that. It's fine with that. So, okay, we've got to leave them on random. We've got to leave them, obviously, whenever we have arguments to those functions, but we can set this to if core part tag equals this, A. Wonderful. And CB, we can get rid of that. And copy B, rename B, and run this. This can't be shrunken down anymore. I mean, we could use a smaller file name, but I don't necessarily want to do that. If D, H, and man, doesn't that start to look really, really ugly. If DH, what does that even mean? Nobody knows. Else if this, and okay. So, now, I think we've replaced out all of the names that we could possibly do. And this is kind of what you would do if you were writing a minification script, that it basically does all of this. Now we've got to start getting even uglier. And this is stripping out all of the additional new lines here. And let's see, local. Actually, you know what we can do? We don't even need local. We can say set. That's shorter. Are we using local elsewhere? Yep. Set and set. Oops, not set. Return K. That's still return K. Are we using local anywhere else? All we're doing is going through and finding all of the various hacks that we can do. And you see now we're down to the point where this this entire script fits within one line because of a lot of ugliness. And we're going to start stripping out the new lines now that we're getting here. So set n. Oops. If we're doing set, we need to use 2. Local. Yeah, set 2. All right, let's start shrinking this stuff up. And in some of these cases, we can get away with removing spaces, but occasionally that can confuse the compiler, so I'm not going to get that rigorous about it. I'm going to preserve spaces. Actually, it doesn't really matter if I'm preserving spaces. No, then I'm not getting any benefit here. Switch to that, return that, and yeah, we're removing all of these spaces. See, isn't that just the worst? Copy B from that, rename that. Oops. And that. We're just making this thing as tiny as we can possibly get it. We're relying on the compiler to go, okay, there was a period, therefore that's the end of the expression. Else if this runs start, okay, can't shrink that anymore. We'll go down here. And there. And look how ugly this is. N list files in the for F and L if M name equals this. We can get rid of these. And we're saying return 1 dot return 0. This is just absolutely awful. But hey, it's tiny. So that's something. If equals, we don't need spaces there. And we don't need spaces with this plus. We're just finding all of the ways that we can conserve any possible characters, because white space do count as characters, and they're going to make things slower for us. So let's go here, convert this to n plus, lots of white space we can destroy and make ugly here. If n length is greater than this, set this to this, good, and there we go, and there. All right, put that up in the function body, and then it's just a matter now of collapsing all of these functions into one line. And getting rid of this. And the last one. There we go. Now we have one absolutely terrible. Actually, there are a couple more, I think. I think that should still work. We're going to obviously have to go ahead and run and test this to make sure that things are still fine. But let's go ahead and check the final character count. We've gotten this down to 511 characters. And I don't think I can pull off anything better than that, at least for now. Let's go ahead and try running this and just see exactly what ends up happening. So I'm going to go ahead and copy this over to volumes, Kerbal space program shipped script, minboot.cas. We're not actually setting it up as a boot script just yet. I'm just going to go ahead and try running this. Let's see. Clear screen. And let's just see, first off, if I can run it. Let's see. Switch to 0. Run minboot. Nope. Okay, now it's angry. What's it angry about? If core part tag equals this, a return core part tag. Okay. Core part tag equals, all right, if that does that fix it? Let's see. Where are you mad? Where are you mad? I don't see your indicator. Where are you mad? Let's clear screen real quick. Expecting end of expression. Okay, no, it's still mad. Oh, right, I didn't copy this over. Copy it over, run it again. Now it's mad about, okay, so that did fix that. Yeah, occasionally once you start to get into minification, it really confuses the parser. So now we're on to another thing. If, where? Right, else if, C start. Okay, if dh. Okay, well, we've gotten pretty far through this already. If dh, let's try that. Copy that over again. It ran, huzzah! Okay, so now we have this tiny and terrible thing. Now we've actually got to test if it does stuff. So let's go ahead and, let's see, log print5 to startup.ks. Wait, nope, not there. We need to switch back to our regular volume first. And log print5 to, just do that. And switch to, let's see, copy minboot from 0, run minboot. 5.5. Okay, it ran it twice. Why did it run it twice? Oh, yeah, no, we were already on the archive volume, or we were already on the local volume. That's fine. Alrighty, so that part did work. Now we need to see if it will grab new instructions. So I'm going to say, I'm just going to print off the core part tag. Hello. So if we have an instruction called hello.update.ks, then it should pick it up. So let's go ahead and write a new file real quick. Hello.update.ks. I'm going to say print hello from hello.update.ks. And I'll copy this over to the archive volume as hello.update.ks. There we go. And run minboot. Hello from hello.update.ks. That's what we expect. If there are new instructions, it should run it. And actually, let's list the files in the current volume. Now, you see it's got that startup script. It's also got the temp.exec.ks script as well. That's good. I think that's good, right? Yeah, that's good. And it's got some, there's some other files on there from other stuff that I've been playing with for new versions of KOS. But the last thing that we want to, no, we don't even have to test that. We know that it's only going to run the startup script if this doesn't exist yet. And yeah, we know that this works now. So this absolutely terribly ugly code, let's go ahead and take a look at it in all of its ugly glory. Boot.ks. There we go. There's the entirety of our boot up script ready to go and power us on to new worlds. It's now been updated so that it removes some of the stuff that we weren't using, and it isolates everything that it runs so that we don't end up encountering issues with naming collisions, and it's going to handle multiple core instructions. Now, the one thing that it won't handle is removing those instructions after they've been run, and that's actually deliberate because I end up reverting stuff a lot, and I want to not have to worry about it. That basically it'll be my job to go ahead and remove the file before reboot if I need to. Otherwise, it'll go ahead and rerun it when I quick save or quick reload. So there we go. We've gone ahead. We've rewritten a boot script. It is ugly and it is gross. But, oh, no. There's one last thing that we need to test, and that is, let's set core part tag to empty string and run minboot again and print core part tag. And there we go. We've had it, and now it will automatically assign a tag to the part if it does not already exist, and now it will go ahead and check that file .update.ks for any new instructions. So we now have a boot script that will power us into future and further generations of spaceflight, and it is only 515 characters long. I will see you all in the next episode. Cheers.